dalam topik elektrik, kita belajar apa? What do you remember? What you learn in topik elektrik? So, yang you belajar, current and potential difference. Okay, and then ada experiments, activities. Okay, and then you need to know how to draw the electric field region. Yeah, positive charge, outwards, out. Kalau negative, inwards. Okay, and then we have formula for potential difference. Okay, and then electric current formula I equals to Q over T. Okay, and then you learn about resistance. Okay, and when resistance, we have ohmic conductor. So for ohmic conductor, it obeys Ohm's law. So kalau Ohm's law, ohmic conductor. So Ohm's law states that voltage is directly proportional to the current. Right? So when this happens, kita dapat R constant. Okay, and then we have non-ohmic conductor. So what is non-ohmic conductor? Non-ohmic conductor, okay, when you get an non-ohmic conductor, so this is the graph. Macam mana graph tu? It's a curve graph. Okay, curve graph passing through the origin. Okay, so what it says? So kat sini awak nampak lah, as current increases, voltage also increases, tapi dia tak proportional macam ni. Okay, so we say resistance increases once you increase the current. Kalau yang ni resistance constant. Lagi apa yang kita belajar? Okay, and then kita tengok, you need to know about series and parallel circuits. Okay, tengok ni kalau series circuit, I dia equals to I1. Ni I1, this is I2, this is I3. They are all equal when during series. And then what about the voltage? Ni total voltage. So if total voltage equals to V1 plus V2 plus V3. Okay, and then R, the resistance, R1 plus R2 plus R3, then you get the total resistance. Okay. Now what about parallel? So parallel, so now look at the difference. So kalau parallel, ni. Now, tengok kita ada junction dekat sini. Okay, current flows from here. Ni positive, ni negative terminal. So current travels through here. Now dia ada junction. Dia kena ada simpang. So daripada banyak-banyak tu, dia nak kena bahagi. Sini sikit and some of here. So this one we call it I1. Ni I2. And then we have I3. Dia dah pecah lah total dekat sini tadi banyak. And then dia dah pecah-pecah jadi sikit lah. So R1 only gets I1. R2 only get this amount, I2. R3 only dapat I3. Tapi once the charger ataupun the current sampai junction ni balik, kita add them up, dapat balik total current. So dapat macam ni lah. You kena tahu kan. And then what about the voltage? So voltage, ni total voltage. Ni total voltage. So this total voltage equals to voltage 1 equals to voltage 2 equals to voltage 3. Okay, and then kita ada the resistor. Jadi yang ni selalu student salah. 1 over R equals to 1 over R1 plus 1 over R2, 1 over R3. Once you dapat jawapan, contoh you dapat jawapan berapa? Contoh ini adalah 1 over 3. So ni 1 over 3 ni is not the resistance, it's the 1 over R. 1 over R equals to 1 over 3. Therefore, kalau nak cari R dia berapa? 3 over 1, which is 3 lah. Kita terbalikkan saja. Okay? Right, so let's look at the question. Now ni, kita ada 12 volt battery. Okay? 12 volt battery consists of cells connected in series. Okay? So cells ni in series. Each cell in the battery has an electromotive force of 1.5 volt. Okay, so determine how many cells are in the battery. Do you understand the question? Faham tak soalan tu? Jadi dia kata kat sini total 12 volt. Right? So, dia kata kat sini bateri. Nampak tak bentuk dash ni? Dash lines ni. Apa maksud dash lines tu? Dash lines tu, apa maksud dash lines? Maksud dash lines tu sebenarnya kita bukan hanya ada tu dry cells saja. Maksudnya dash 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 ni maksudnya dekat tengah-tengah ni ada lagi a few other batteries. Tapi soalan tanya how many? Berapa banyak lagi dekat dalam tu? That's why lah kita guna dash dash tu. Faham Jadi dia kata total is 12. Tapi dia kata each cell, ni satu cell. Each one ni is 1.5. Jadi how many cells ada? Siapa boleh teka? Macam mana nak buat? Kalau 1 is 1.5, jadi nak nampakkan number of ni berapa? Dia macam ni lah, 1.5 volts untuk 1 dry cell. Betul tak? Jadi kita sekarang ada berapa? Kita ada 12 volt. Jadi kalau 12 volt, macam mana nak capai? 1 over 1.5 times 12 volt. Okay, jawapan dia 8. Ada 8 dry cells. Okay, B1. When the switch is closed, the ammeter reading is 2.4 amps. Okay, when the switch is closed, the ammeter reading is 2.4 ampere. Calculate the total resistance of the circuits. So, berapa? Calculate the total resistance of the circuit. So, kita nak buat formula, senang. So, kita ada formula V equals to I R. So, current. You have current. 2.4 is the current. Okay, and then the voltage. Oh, how much is the voltage? Total voltage tadi? Given as 12. Okay, jadi kita ambil. Masukkan saja what do we want? We want total resistance. So, rearrange the formula. Therefore, R equals to V over I. So, what's V? 12 volt. What's the current? 2.4 ampere. So, dapat berapa? Tekan kalkulator, dapat berapa? 5. Berapa?
5 ohm.
5 ohms. Okay. Right. So, senang sahaja. So, you kena okay, and then number B2. Each lamp has a resistance of 3 ohm. Calculate the resistance of Q. Okay, dia kata kat sini each one 3 ohms. Ni pun 3 ohm. Okay, calculate resistance Q. So, Q berapa? 2. Okay, Q. Kita Q, which one is Q? This one. Okay, Q dekat sini. Jadi, now you kena tahu. Kalau if you want to use V equals to IR, V equals to IR, okay, kita boleh dapatkan R. What is the total R? Okay, so V total, I total, R total. So, you dapatkan dulu R total. And then, you cari. Okay, yang ni secara apa ni? Ni secara parallel. Kan? So, cari dulu. Secara parallel tu macam mana? Tengok saya buat macam ni. Kecil lah, nampak tak? So, okay, kita nak Q soalan nak Q. Saya buat kat sini sebab I want to look at the diagram. Okay, questions nak what is the resistance Q ni? So, that's the question. Okay, first you need to know what is the total R. Okay. Now, how can you get the total R? Okay, kat sini dah tanya dah sini. Total R. Jadi, you don't have to calculate anymore. So, now you know the total resistance for this whole circuit is 5 ohm. We have calculated that already. 5 ohm. Okay, however, okay, kita nak tahulah macam mana. Okay, yang ni 3. Ni each one 3, but they are in parallel. So kita dapat macam ni lah. Cari dulu. What kita need to find, need to find the resistance in parallel berapa. Kita nak tahu dulu berapa resistance yang ni. Jadi macam mana? 1 over R in parallel equals to 1 over 3 plus 1 over 3. You boleh buat sama-sama ataupun you can check your answer. Okay, and then 1 over 3 plus 1 over 3 equals to, tekan calculator, that gives us
2 over 3.
2 over 3. So, what is the R in parallel? So, ingat, yang 2 over 3 ni is equal to 1 over R in parallel. So now kita nak R parallel saja. Kita bukan nak 1 over parallel. So that's 3 over 2. 3 over 2 is 1.5 Betul tak? 1.5
Betul, teacher.
Okay, jadi sekarang seolah-olah kita ada circuit yang macam ni. Ni resistance dia 1.5 ohm. Ni R. Seolah-olah kita ada macam ni. Okay, kelas. Kalau kita ada macam ni, kan, kalau kita ada macam ni, okay, macam mana kita nak dapat this 1R ni? Senang saja, series. Ingat tak tadi yang saya tunjuk ni? In series, bila in series, dia macam ni. Tambah. Dapat. Okay, so dapat macam mana? So,
R series sama dengan R total tolak R parallel.
yes, jadi kita dapat R, okay, so kita nak dapatkan R in series tu, R equals to total 5 minus 1.5 ohm. So that's the answer. So dapat berapa? 3.5 ohm. Susah ke senang? Senang saja. So jadi first you kena cari dulu R total, dah dapat. Jadi R in series sama dengan, R in series sama dengan R total minus R in parallel. Jadi you kena cari dulu R parallel berapa. Jadi you dah buat dekat sini, dapat jawapan. Okay. So sebenarnya jalan kerja ni semua awak letaklah. Ni semua you can show in your answer. Kan? Okay, letak semua tu kat sini. Sebagai jalan kerja. Buat jalan kerja tu satu-satu. Jangan nak skip lah. Alright, yang ni tak penting pun tak apa, gambar rajah tu. Cuma gambar rajah ni you kena faham. Kan, bila kita combine dia, when we combine all the two bulbs, kita dapat value dia 1.5 saja. Right, so this is the answer. Next, on figure 7.1, draw the symbol for a voltmeter that measures the potential difference across the two lamps. Jadi kat mana jawapannya tu? Jadi kita nak di sini. Sebab soalan kata dia nak across the lamps. So, you kena buat lah. So, kena ingat. Voltmeter always in parallel. Kan? Voltmeter mesti in parallel. Jadi, kalau in parallel, okay. Calculate the power supplied to one lamp. Okay, so C2. Calculate the power supplied to one lamp. Kalau soalan C ni, kita tukar, kalau soalan tukar, yang ni dia nak potential difference. Kalau dia nak ammeter, tengok. Ammeter must always connected in series. Okay, calculate the power supplied to one lamp. Dia nak one lamp sahaja. So what's the formula for power? Power equals to Phi ataupun IV. Do you know the V? For each lamp.
Sure.
Soalan nak lamp. Jadi for each lamp, what's the voltage? Soalan
1.5 1.5.
1.5. Is it? Eh, 1.2. Sekarang ni dia ada bagi tak voltage across one lamp sahaja, one lamp sahaja, ada tak? Tak ada kan? So macam
Tak
mana?
ada, teacher.
So macam mana awak nak dapatkan the voltage? Where can you find the voltage? Kita dapat 3.6 as the voltage. Mana dapat 3.6 tu? Kat sini lah sebab macam ni. You dah tahu kita tak boleh guna 2.4 ni. Kita tak boleh guna 12. Sebab 12 ni adalah voltage for all of this. Untuk semua sekali ni. Jadi sekarang untuk for each ni, bab berapa? So senang je lah. Kita cari dulu current pada each bab. So current for each bab, tadi dah draw kat sini kan? Ya. So kalau sini, kita cari berapa voltage pada, okay, you tengok gambar ni. Ya, saya copy balik. Okay, sekarang ni 3 markah. So, tengok ni. Saya lukis kat mana ni bagi nak ruang. Okay, now. Okay, you know voltage dekat sini. Okay, kita nak tahu voltage. Tengok ni. Ni selalu student tak. Sekejap macam ni ni. Okay. Mana tadi? Okay. So, ini in series. Betul tak? Gambar ni kita nampak dia in series. So, in series is this one. Okay. Now, voltage macam mana nak dapat? 12 tadi adalah for all of them. 12 tadi. Jadi, kita tak boleh dapat 12. So, kita nak tahu kat sini, kita carilah berapa voltage here. And then, berapa voltage here. Ada tak mana-mana tadi yang kita kira voltage for one part sahaja? Tak ada kan? Okay.
Tak ada, teacher.
Kita cari dulu voltage dia. So, sekarang ni untuk kita tak payah kisahlah yang ni sebab kita tak nak tahu about this resistance. Kita nak tahu for the lamp sahaja. So, across the lamp tu, the total resistance berapa? Total resistance 1.5 kan? Ni for lamp. Okay. Total resistance dia, 3 lah. For each battery. 3 ohms. Jadi kalau 3 ohms, kita buat macam ni resistance lamp 3 ohms. Jadi V dia berapa? So V dia equals to, V equals to IR. I for lamp, V over R. Sorry, kita nak the jadi kita dapat 3.6 and then V equals V, okay, and then kita dapat, therefore P equals to VI, dapatlah 1.2 times 3.6, jadi dapat 4.3 watt. Dapat tak? 4.3 watt. Okay, yang ni jalan kerja je lah, tunjuk kat sini. Okay. Okay, ada soalan? Dapat tak? 1.2 times 3.6.
Dapat, teacher.
Okay. So, dapat 4.3 watt. Okay. So, untuk 2022 ni, ini sajalah soalan elektrik dia. Kita tengok lagi satu contoh soalan elektrik. Okay. Now, okay, ni electric field. State what is meant by the direction of electric field. Electric field is the region. Region apa? Ni, you all nak juga ke bahan yang ni? You just need to know. You if you read, you can answer. So what is meant by the direction, ya? Soalan bukan tanya what is electric field. Tak. Soalan ask you what is the meaning of direction tu. So direction tu menunjukkan apa? The direction tu shows the direction of, apa dia kata? It is the direction of the
Electric force.
force, yeah, the force on a positive charge. You kena mention this one. So the word force is important. Force tu di mana? Force on a positive charge. Okay, next. Number 2, figure 9.1 shows a pair of oppositely charged horizontal metal plates with the top plate positive. Okay, the electric field between the plates in figure 9.1 is uniform. Draw lines to represent this uniform field. Add arrows to these lines to show the direction of the field. So this is not difficult. So you kena tukis at least 3 lines. Jadi, so buatlah line tu and mesti equal distance, ya. Equal distance tu maksudnya dengan mata kasar nampak dia lebih kurang sama besarnya. Jarak ni ke sini lebih kurang sama. Okay, next. Dia kata direction. Direction positive to negative or negative to positive? Ingat tak positif? Kalau positif tadi charge dia outward ke inwards?
Outward.
Outward. Okay. So kat sini ni positif. Jadi dia ke bawah ke dia ke atas? Dia ke bawah. Tak boleh lah. Tak payah buat banyak-banyak line. So buat 3 sahaja atau 4 ni pun boleh lah. Okay. Next. Figure 9.2 shows a very small negatively charged oil drop in the air between a pair of oppositely charged horizontal metal plates. The oil drop does not move up or down. Okay, suggest in terms of forces why the oil drop does not move up or down. Okay, oil drop ni dia kata very small, dia ada charge. It is negatively charged. Okay, so it is negatively charged and then dia terletak dekat sini. Kenapa dia tak ke atas, dia tak ke bawah? So for first one, you kena cakap, okay, dia ada upward force dan dia pun ada downward force. Okay, sekarang ni kenapa dengan upward force tu? So sekarang ni, kenapa saya kata dia ada two forces ni? Kita tahu tak? Sebab dia kata dia the oil drop ni does not move up or down. So bila dia does not move or up and down, maksudnya the force upward sama nilai dengan force upward. Jadi the upward force due to the electric field. Okay, so that upward force is equal to weight of drop. So you see, apa yang saya dah tulis tadi, sekarang ni apa yang saya cakap tadi, I write it in word. Upward sama dengan nilai bawah. Bawah tu apa? Bawah ni W. Yang ni force upward. Okay, so that's baru first point. Ni 2 markah. Second point apa dia? Now, kenapa dia tak bergerak atas ke bawah? Sebab kita dah belajar tentang resultant force. Dia dah sama. So, tadi saya cakap je lah. Saya buat lukisan sama panjang. Ke atas dengan ke bawah hampir sama panjang. That means there is no resultant force. Ataupun the forces, ataupun you boleh kata the forces are in balance. Faham Now, number 2, without
Teacher,
yeah,
for this soalan, boleh ke kita cakap pasal equilibrium?
boleh? Siapa yang equilibrium? The oil drop. So kita kata the oil drop is in equilibrium. That means there is no resultant force. Samalah tu. Okay, number 2, without losing any of its charge, the oil drop begins to evaporate. Boleh bayang tak? Oh, dahsyat soalan dia. So dia dah evaporate, mungkin dia tinggal sikit je lah kan. Yang lain tu semua dah evaporates. State and explain why, what happens to the oil drop. So bila dia dah evaporated sikit, apa terjadi? Dia makin ringan ke dia makin berat?
Makin ringan.
Sekarang dia ada besar ni. It was here. Tapi bila ada yang dah terbebas, so dia makin smaller. So kita kata the W is lesser. Tadi W ni besar ni kan, ataupun panjang. Panjang ni. Sekarang W pendek je. But do you change the field punya strength? Kan, yang ni. Do you change the field strength? Tidak. Jadi kita kata upward force tu masih sama nilai. Saya lukis sama panjang lah jarak dia. So upward force ni nilai dia masih sama. Jadi what happened to the, nampak dia dah tak balance dah. So you see sekarang force upwards greater, longer kan. Yang ni force downward shorter. Forward W ni shorter. So kat sini kita kata the drop will move up or down. Drop moves upwards. Kenapa? Ni dua ni kena explain lah. Kenapa? Kenapa? Sebab siapa yang berkurang tadi? Weight. Weight ataupun mass of oil droplet decreases ke bertambah? Decreases. That's why. Okay. Next. A plastic rod is rubbed. Mana plastic rod? This one. Is rubbed with a cloth and become positively charged. Di mana? Jadi sekarang siapa yang positively charged ni? The plastic rod. So this one. So kita tulis lah. Okay. And then after charging, the rod is held close. Kita ambil dia, kita bawa dia to the suspended table tennis. Jadi kita bawa ni dekati light table tennis. So now the table tennis ball is covered with metal pin as is uncharged. So ini sekarang neutral. Maksudnya neutral, dia ada positive charge dan dia ada same amount of negative charge. Okay. Sebab dia kata uncharged kan. Now, describe what happens to the charges in the metal pins. Metal pin tu kat mana? On the ball. Yang ni. As the positively charged rod is brought close to the ball. So, akan berlaku apa? Akan berlaku induced charges. Maksudnya, apa yang akan berlaku? Now, okay, ini positif. Right? Ini positively charged. So, siapa yang akan terattracted pada this rod? The negative charge of the ball ataupun the positive charge in the ball? The negative charge. Sebab dia opposite attracts. Kalau same, repel. So, kita kata electrons move. Electrons from the metal pin ni lah yang akan move towards the rod. Jadi bila dah macam tu, apa akan berlaku? Okay. So dia akan so itu je lah soalan dia. Saja buat garisan panjang-panjang ni. So dia tanya what happens to the charges. So senang je jawapan dia. Electrons ni akan mendekati. Dia belum pergi lagi tapi dia akan mendekati positively charged. Okay. The ball is attracted towards the charged rod. Explain why this happen given that the ball is uncharged. Dia kata ball is attracted towards the charged rod. Kenapa? Kenapa awak nampak dia akan cuba mendekati tu? Okay. Sebab apa? Ada negative charge dalam the ball, kan? So, the negative charges are closer to the rod. Okay, lepas tu attraction ada apa? Attraction between opposite charges greater than repulsion between like charges. Okay. State the unit which electric charge is measured. Do you know? Coulomb. Okay, kita tengok soalan lain lagi. Boleh? Shows two parallel conducting plates connected to a very high voltage supply. A left hand plate is positively charged. Dah tunjuk dah. And right hand plate is negatively charged. On figure 10.1, draw the electric field pattern produced between the charge plates. Use arrows to show. So, sama je jawapan dengan soalan dengan tadi. Jadi, macam biasa, kita lukislah 1, 2, 3, arah ke arah. Okay, yang ni macam tak berapa betul ni. Kita nak lebih kurang sama je. Positive to negative. Positive outward, negative inward. And then a light conducting ball is suspended by an insulating string. Shows the ball in the middle of the gap between the planes. Okay, ada ball. On figure 10.2, show the distribution of charge on the ball. Okay. On figure 10.2, show the distribution of charge on the ball. Jadi, bila ball tu tengah-tengah, saya nak tunjuklah, saya ada satu gambar. To show the distribution of charges on the ball. So, dia kata, the ball in the middle between the plates. Jadi, macam mana you akan draw the distribution of charges? Sama banyak ke lebih sikit?
Sama banyak.
Jadi, sama banyak tapi macam mana? So, kita ada right kat belah kanan. Okay, macam kita bagi half. So, yang on the right one, kita ada positive. Kan, positive, positive. Now, why is negative? Negative dia akan 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then make sure equal number. Bila awak nak lukis, you kena ada equal number. Kenapa equal number? Sebab dia tak bersentuh lagi. The ball has not touched the plates. Jadi maksudnya ball tu masa tu dia neutral. Jadi sekarang bila kita letak ke tengah-tengah, dia hanya induce saja. The electron masih lagi belum melompat ke plate tu. Alright, and then the ball is displaced to the left. Jadi sekarang kita ambil bola ni, kita letakkan dia, rapatkan dengan positive plate tu. Okay, and oscillates backward and forwards between the two plates. And then dia kata the ball touches at a plate once every 0.05 second. Every time it touches a plate, a charge of is transferred. Calculate the average current produced by the repeated transfer of charge. Jadi kita nak guna formula apa? Kita guna formula yang saya sebut awal tadi. Q equals to I T. Kita ada formula lain. Q equals to NE. Lepas tu kita ada Q equals to IT. Tapi yang ni tak sesuai lah for this question. Because kita nak I. Jadi I equals to Q over T. Okay. Jadi berapa kita punya charges? Every time 2.8. So 2.8 times 10 to the power of negative 8 coulomb divide by the time. Time dia berapa? 0.05 second. So nampak sekali lagi cikgu tulis unit-unit tu. So tekan calculator, you dapat berapa? You dapat about 5.6 times 10 to the power of negative 7 ampere. Ataupun kalau student tak tahu, dia boleh jawab lah. 5.6 times 10 to the power of negative 7 coulomb. Nampak tak ni? Coulomb per second. So you boleh tulis juga coulomb per second tu sebagai coulomb per second macam ni. So tulis pula jawapan kat sini, times 10 to the negative 7 ampere. Kalau you tahu current unit dia ampere. Kalau tak tahu current unit dia ampere, you tulis je apa yang you buat kat sini. Pun diterima. Okay. Now on figure 8.1 shows a circuit containing a battery of EMF 12 volt and a heater of resistance 6 ohm. State what is meant by EMF. Jadi EMF tu apa? EMF is the energy transferred per coulomb ataupun per unit charge. And then okay, so kenapa? Betul macam mana energy transfer per coulomb tu from where to where? Okay, from where? Macam mana? Per coulomb to drive, energy transfer per coulomb to okay, ataupun energy transfer kat sini kan, kita ada charges. Tapi charges ni berkumpulan. Satu kumpulan berapa? Coulomb. Satu kumpulan, satu coulomb. Satu coulomb, satu coulomb. So dia kata, okay, jadi kalau sekarang kita fokus pada satu sahaja. So katalah kita ada 1 coulomb of charge ni. Sekarang 1 coulomb of charge ni, it was here just now. Okay, it was here kat sini. Kita ada 1 coulomb. So yang this 1 coulomb ni, okay ni, kita bawa ke sini. Itulah maksud EMF. Okay, daripada sini ke sini. Daripada terminal ni ke sini. Alright, jadi daripada mana ke mana tu? In bringing okay, so coulomb into to around okay. Voltage across battery power supply. Okay, calculate the current in the heater. Alright, calculate the current in the heater. Formula V equals to IR. So what's your I? I itulah yang kita nak tahu. Okay, jadi kena rearrange the formula. So I is the one that we want. We know the voltage 12 volt. And then dia nak on the heater, in the heater. So now you know the resistance of the heater. Soalan IGCSE ni senang je lah. So 6 bahagi 12, 2. So dapatlah 2 V over ohm ataupun 2 ampere. Okay, so 2 ampere. State the name of particles that flow through the heater. Apa particles yang flow through the heater? So sebenarnya tadi yang saya bawa bergerak-bergerak ni, apa ni sebenarnya? Apa yang dalam 1 coulomb? The charges. Tapi charges tu apa? Charge positif ke yang negatif? It's the
negative.
Yes. So the negative ones kita ada nama, which is electrons. Okay. Sorry. Okay, calculate the thermal energy. Okay, in figure 8.1, draw an arrow next to the heater symbol to show the direction of flow of these particles. Okay, you faham soalan 3 ni, you kena hati-hati. Soalan nak direction of current ataupun direction of electron.
Direction of electron.
Yes, jadi kalau direction of electron dari mana ke mana? So electrons travel from negative terminal to positive terminal. You tahu tak negative terminal mana satu? Negative terminal yang pendek ni. Okay, kalau positive terminal yang panjang ni. So electron travels from negative. So electron macam tu direction dia. So arah you buat, dia kata tadi apa? Draw an arrow next to the heater symbol. Jadi awak buatlah ke sini. Yeah, this one. So this is the answer. Okay. Yang ni tak payahlah sebab dia nak satu saja. Tapi if the question asks about the direction of current, so this is the direction of current. Conventional current. So boleh faham tapi untuk soalan ni you tak payahlah draw yang ni. Sebab dia nak okay. Now calculate the thermal energy produced in the heater in 10 minutes. Calculate the thermal energy produced in the heater in 10 minutes. So macam mana? C. So apa formula yang kita ada? E equals to kita nak, kita tahu P equals to VI. Ini you dah hafal ke belum? And then kita tahu V equals to IR. So sekarang ini tak relevant, tak boleh guna. Tapi kalau you nak guna yang ni, tapi tak ada time. Kita nak yang ada time. Jadi kita nak buat macam mana? Okay, yang ni tak boleh guna. And then you tahu tak ada formula power equals to energy over time. Betul tak? Okay, and then daripada sini, kita boleh dapatkan energy. Ni you rearrange this formula. E equals to P times T. P times T. Okay. Jadi when P times T, so kita ambil balik formula tadi. E equals to, soalan kata ni calculate the thermal energy. So question wants the thermal energy. Soalan nak energy. Jadi berapa energy dia? So inilah yang kita nak. Inilah yang soalan nak. E. Okay, tapi kita tak tahu power. Do we know the power? Tak. So
No, teacher.
Jadi power equals to VI. Power equals to VI. So you substitute VI T. Jadi now you know V. Do you know V? Tahu. Tadi V kita diberi berapa tadi? 12. And then I dah kira tadi berapa? 2 time dia berapa? Is it 10 minutes? Tapi tak boleh dalam minit kena tukar kepada second. Okay, sebab energi ni nanti akan dalam unit joule. Kalau nak guna unit joule, kalau if you want to use joule as the unit, so you have to make sure ni semua dalam SI unit. Volt, ampere and second. So tekan kalkulator. Darab 12 darab 2 darab 10 darab 60. Berapa Siapa tekan kalkulator? 12 kali 2, 24. 24 kali 6. Berapa you dapat?
14,400 joule.
Yes, 14,400 joule. So kalau saya tak bagi tahu tadi unit dia joule, you tahu tak unit dia joule? So you kena tahu.
Tak tahu.
Jadi kalau you so kalau tak tahu you kena tahu lah So joule ni you kena pastikan masa ni dalam unit second. Okay. A digital watch is powered by 1.3 volt cell. The cell supplies a current of 4.1 times 10 to the power negative 5 ampere for 1.6 times 10 to the power 7 second. Calculate the charge that passes through the cell in this time. Okay, kita nak guna formula apa ni? Kita dah banyak formula kita tahu. Q equals to IT, Q equals to NE, V equals to IR, P equals to VI. Mana satu formula yang paling sesuai? Kita nak apa yang ni? Kita nak charge. Jadi the only formula yang we can use is Q equals to IT. Okay. 4.1, so macam mana? Do you know the current? 4.1 times 10 to the power negative 5 ampere.
Yes, teacher.
Okay, time 1.6 times 10 to the power 7 second. Okay, so 360 coulomb. The resistance of kita nak cari pula resistance dia. Jadi V equals to I R. Okay, now kita nak R equals to V over I. Jadi V itu adalah 30,000. Sorry. Jadi V itu berapa V dia? 1.3 kan? 1.3, jadi tulis 1.3 V. Current adalah 4.1 kita dapatlah 32,000 ohm. Okey, so dapatlah 32,000 ohm. Okey. So the output power of the cell. The output power of the cell, kita nak guna formula apa? So banyak cara kita boleh guna. So you boleh guna P equals to VI. Jadi VI, so kita tahu V which is 4.1 times 10 to the power negative 5. Do you know the voltage pun kita tahu. Jadi simple. Kita boleh guna this formula sahaja. So dapat berapa? Kalau ni lebih kurang 5.3 times 10 to the power negative 5. What is the unit for power? Watt. So 5.3 times 10 to the power negative 5 watt. Okay, so kita dah buat beberapa soalan elektrik. Kita dah tengok charges, electric field. Kita dah guna formula V equals to IR. Kita dah guna formula P equals to VI. Kita dah buat soalan elektrik kan. Jadi yang ni pun soalan yang macam menarik favorite jugalah dalam IGCSE. Ni tentang induced charges. Okay, induced charges ni boleh ke mana. Okay. Alright. And then ni pun kita dah cakap tentang electric field. Small positively charged. Yeah. So, sketch pattern. Ni you dah tahu tadi, kita dah buat awal tadi kan. Cuma kan, ada student dia suka buat macam ni. So ini, lepas tu walaupun dia buat anak panah macam ni, salah Apa yang salah dia? Jarak dia jauh. So kita pastikan dia dekat je. Dia kena betul-betul touch the charge. Okay, yang ni pun dah tengok. Okay. So kalau next time kita boleh tengok lagi beberapa lagi contoh tajuk elektrik yang tak buat lagi. Boleh? Okay? Aku sambung lagi.
Boleh teacher.
Alright, ada soalan tanya apa-apa? Yang ni dah topik elektromagnet. Minggu lepas kita dah sentuh kan. Ni ada 2 bars. Okay. And then ada charge. Okay, on figure 7.1, draw a single line with an arrow to show the direction of the magnetic field due to the bar magnets. Okay, mana arah dia?
North to south. Upwards.
Okay, jadi straight line up and down page kan. So dia kata ni macam ni betul. Okay, lepas tu arrow to up ke down? To the south. Okay, now state the direction of the forces exerted on the vertical road. Ada force. You ingat tak you dah belajar force?
Ingat teacher.
So apa arah dia? Ke kanan, ke kiri, ke atas, ke bawah?
Ke kanan.
Mana you guna? You guna Fleming's left hand rule. Jadi kan? Fleming's left hand rule. So you punya jari paling, kita ada jari macam ni lah. Katalah ini your index finger, ini your middle finger, and this is your thumb. Okay. Lepas tu macam tu lah jari-jari yang lain tu kan. Macam tu. Okay, nampak pula. So, yang ni tunjuk arah current. And then yang ni tunjuk arah south. And this one is the force. Okay, sekarang kita nak tentukan force tu ke mana. Kan, kita nak tahu force ni ke mana. Jadi, kita gerakkan ni current. Current ke mana? Current ke bawah kan. Jadi, bila current ke bawah, current ke bawah pula. Current into the page. And then south. Ni tunjuk south. Okay, awak gerakkanlah jari awak tu. So, current into the page ke out of page? Out of page. And then south ke bawah. So, force kita. So, the vertical rod will move towards the right. Okay, tapi dia nak jawapan dia suruh state the direction. Jadi jawapan awak you tulislah. Direction dia adalah to the right. To the right. Dia tak suruh explain. Okay. Alright, I think that's all for today. Nanti kita boleh sambung lagi untuk next class next week. Alright.